Hello students, welcome to next video on solubility of drugs. In this video, we are going to study in detail about solubility of gas in liquid as well as solubility of liquid in liquid. So let's begin with solubility of gas in liquid. The solubility of a gas in a liquid is the concentration of the dissolved gas when it is in equilibrium with some of the pure gas above the solution. Gas like hydrochloric acid, ammonia water, and effervescent preparation containing carbon dioxide that are dissolved and maintained in solution under positive pressure. Then, aerosol product containing nitrogen or carbon dioxide as propellant are also considered to be solution of gas in liquids. The solubility of gas in liquid is greatly influenced by the first one is nature of gas and the solvent. So, depending upon the nature of gas and solvent, it is going to be defined that how much amount of gas is going to get solubilized in the respective amount of solvent. Then, the next important factor affecting solubility of the gas in liquid is temperature. So here you can see that solubility of a gas in liquid decreases with respect to increase in temperature. With increase in temperature, the volume of dissolved gas increases and solvent cannot accommodate gaseous solute, resulting into bubbling out of the gases. Another important factor is pressure. So here is the diagrammatic representation of effect of pressure on gas in liquid. It is very clear from the image that on increasing pressure, the solubility of gas in liquid increases. The effect of change of pressure on the solubility of gas is given by Henry's law, according to which solubility is directly proportional to pressure. Henry's law states that at a constant temperature, the amount of given gas that dissolve in a given type and volume of liquid is directly proportional to partial pressure of that gas in equilibrium with that liquid. It is given by the equation P is equal to KHX, where P is equal to partial pressure of the gas, X is mole fraction of the gas in solution, and KH is Henry's law constant. The another factor is salting out. So gases are often liberated from solution in which they are dissolved by the introduction of an electrolytes and sometimes by a non-electrolytes. Then the next is chemical reaction. When gases like HCl, ammonia, carbon dioxide comes in contact with solvent, then chemical reaction occurs readily, resulting generally in increase in solubility. Now let's talk about solubility of liquid in liquid. So the component of an ideal solution are miscible in all proportions. You know that water is a universal solvent as it dissolves almost every solute except for a few. Then you also know that some miscible or completely miscibility is also observed in some real binary mixtures like that of in ethanol and water under normal conditions. Then in some cases where partial miscibility occurs under normal condition, the degree of miscibility is usually dependent upon the temperature. Binary solutions. A binary solutions is a kind of homogeneous mixture in which the mixture of two liquid is completely miscible with each other. Example of binary solutions are in pharmaceutical like that of pharmaceutical solutions of liquid dissolved in liquid. Examples hydroalcoholic solutions, aromatic waters, spirits, elixirs, lotions, sprays, and some medicated oil that contain mixture of two or more miscible liquids. Then binary solution. For binary phase systems such as phenol water system, the mutual solubility of two conjugated liquid phase increases with increase in temperature called as conjugate temperature, whereas above this temperature they are soluble in any proportion. The dielectric constant of a substance also affect the solubility of a substance. Also you are aware about the fact that like dissolves like. Then the next point is The influence of foreign substance on a liquid-liquid system is like the idea of three-component system in the phase rule. For example, ternary systems are produced by adding of third component to a pair of partially miscible liquid to produce a solution. If added component is soluble in any one of the two component, or if its solubility in the two liquid is comparatively different, the mutual solubility of the liquid pair is decreased. However, if added solute is roughly soluble in both the liquid approximately to the same extent, then the mutual solubility of the liquid pair is increased. This is known as blending. After this binary solution, we'll discuss about ideal solutions. An ideal solution is a mixture in which the molecules of different species are distinguishable. However, unlike the ideal gas, the molecule in ideal solution exert force on one another. When those forces are the same for all molecules independent of species, then a solution is said to be ideal solution. Also, a dilute solution consists of negligible amount of solute compared to pure solvents. These solutions are referred as ideal solutions. An ideal solution is one in which there is no change in the properties of the components other than dilution when they are mixed to form the solution. No heat is evolved or absorbed during the solution formation. The final volume of real solution is an additive property of the individual component. Then, ideal solutions are formed by mixing different substances having similar properties, and therefore there is complete uniformity of attractive intermolecular forces. The basis of solubility and solution theory is based on ideal solution. In ideal solution, there is a complete absence of attractive or repulsive force, and therefore the solvent does not affect solubility. However, the solubility in such case depends on the temperature, the melting point of solute, and the molar heat of fusion, that is delta H of F. In ideal solution, heat of solution is equal to delta H of F. Therefore, solubility in ideal solution can be expressed by equation minus log x raised to I 2 is equal to delta H of F upon 2.303 R in bracket T0 minus T upon T0 T, where Xi2 is ideal solubility in terms of mole fraction, R is gas constant, T is the temperature of the solution, and T0 is the temperature in Kelvin of solute. This equation can be used to calculate molar heat of fusion by plotting the log solubility versus reciprocal of absolute temperature, which results in slope of minus delta H of F upon 2.303 R. However, unfortunately, most of the solutions are non-ideal or non-real real because there may be some sort of interaction between solute and solvent. In this, solution may release or absorb some sort of heat from surrounding during mixing of solute and solvent. So, while describing non-ideal solution, activity of solute must be considered. So, this is all about ideal solution. Thank you.